Huh? Can you share from there?
But I'm not on screen. But I can.
Yeah. Or maybe you can just explain from there. That may not be a bad idea. We'll be all muted. You can explain. Oh, let me mute myself. Huh? Yeah. Everybody.
Can make it cute.
Not right.
Hello? Yeah. Are you able to hear us now? Hello, online people?
Yes, we can hear now.
Okay. Yes. Oh, good. Even I can also hear you. Okay, good. So we have done with the tree. So, and I think it will be very difficult to 1, 2, 3, 4. Okay, so we have created a tree with the max depth of 4. And based on this here, so let's see, okay, what exactly. So all the different features are there. Apart from, with the tree structure, we can see with the gender, it's taken as 0.5 or less.
What does it mean?
That's what that's the problem. So gender 0.5. So yeah. So let's see. So gender 0 means okay. M, phi, F is 1. F is 0. M is 1. Okay. So if it is less than 0.5, so that means it will be towards 0 side. And 0 side means female. So if it is female. Yeah. So if it is female, so based on that male or female, it is first dividing into 2 classes.
Okay.
Okay. So on the left side, then again we are bifurcating with the based on P class.
Right side is female or left side is female?
Left side will be female.
Left side will be female.
Yeah.
Okay.
And after we got that female set, then we are doing the classification or bifurcating by means of the P class, passenger class. So if it is less than 3, so I think we have 0, 1, 2, 3, third class, first class, second class. So if it is less than 2.5, then it is going into then again it is based on age. If it is less than 2.5, and then again it is going based on P class once again, and after that it is getting the class I survived. Okay, even in that here in the P class, in the last node, P class less than 1.5, then it becomes the class of survived.
Inventory with the min sample leaf of 50. So for each of the nodes, we should have at least 50 passengers sitting there. Can you try that? And then
Okay, I think that will be at least we will get less.
Right now you can try.
Here.
Let's take a look at the tree.
Min sample leaf.
Min sample leaf is equal to 50.
Min. And a leaf.
Sample underscore
Leaf is equal to 50. Comma. Min sample leaf. What is the?
Spelling MIN or MIN?
Just look up the syntax.
That's what I was trying to.
Just take everything and find out. Remove that no and find out. Until 8 minutes ago. Min underscore samples. Samples.
50. Okay.
Scroll.
Now it looks. It is
a lot more manageable.
Yeah.
Now you go back to the
Okay. Now
Okay.
based on gender.
So now it is same again. So it based on the gender first. Okay. So if it is towards female side, that is left side. If it is female, and the passenger class is less than 2.5. Okay. And then again, fare is less than 36. Okay. And less than 36, it becomes a class of U. U means
U is what?
Unsurvived.
unsurvived.
Okay.
But again, how does it matter? Both are unsurvived, comes as unsurvived.
No, it's the relative quantity that you're looking at. So the 65 and this and 46 and 5, right? So, and similarly for example, over there in the orange part, so you can see there is a blue part and there's an orange part. And there's a color mix up between the blue and orange. So the left side is more survivals. The right side is less survivals. So the blue is more survival. The red is less survival. Yeah.
Blue is unsurvived towards. Blue is unsurvived.
More survivals. It is only.
So you go up to your tree. At the node.
Yeah.
Node.
Yeah.
No, the blue is more survival actually. So I think the labeling is slightly off. So you're looking at the class as a survival, right?
Yeah.
I'll just stop here so that others can also.
Okay.
You can mute. Yeah, something. Okay.
Just a moment.
Yeah, go back to your screen again. Right, so
you're looking at the gender less than or equal to 0.5, right? And that means basically it's a female, which is the right, which is the left side, which is correct, right? I have a bad quality network as well, so let's see. Anyways, now where have you done the class U and S? Can you show me that? You've named them manually somewhere. Where is it getting the U and S from? Where is the U and S coming from is what I was wondering. You haven't done it, and you're also getting the UNS? You're also getting UNS. You're getting UNS. Okay. Okay. So I'll show you maybe my view. Just a second, I'll go back to the same setting. You can mute yourself. I'll just see if I can explain you. Where is the call, the meeting setting here? I mean, I just was able to do it. Hide device setting. Yeah, device setting is right here. Okay. Okay. Folks online, can you hear me okay? Can you confirm?
Yeah, we are able to hear you.
Yes, sir.
Okay. Fair enough. So I'm just gonna walk you through the the code that I have over here in the decision tree. So I don't know where the UNS came in from. I'm a little bit surprised. Huh? Yeah, so that's why I'm wondering where exactly. So you can pass on the class names. I think that may be something that you haven't done. Yeah. So just do it 01. That will be more specific, right? So class name 01. 1 means survival because then that confusion will not be there. That confusion will not be there if you just label it 01. And I will make the tree slightly more busy because I think it's a very, very simpler one. Let's see. Okay, so folks from here, you can just look at my screen. And then I can ask one of you to do the interpretation. So I'm just changing the min sample leaf to 50, min sample split to 200, right? And that gives me this sort of model performance, but I'm not necessarily worried too much about that as of now. I'm more worried about the interpretation part. Yeah. Now this is how it looks like. And I'll show you another thing, folks, that you can do, because sometimes the image interpretation here will be different. So what you can do is graph.render. So you can try graph, the graph that you had earlier on, you can try graph render and just name that as the image that you want to save as. You've done it? Okay. And then you can go to your folder and you'll see that there's a file which is generated over here, right? Now you can download that file. I'm assuming that if you've called it graph or something, then you can just, graph is this final object that you're plotting. The final object that you're plotting will be called graph or something of that nature in your file. Huh? This will be there only. I will skip. You can give to these folks. No. Are you able to get the graph? No. And that will be saved as a PDF and as well as a PNG. Right, so then you can download that and it becomes easy to sort of like visualize what is happening, right? So if I click on the PDF, for example, now you can see this is fitting in one page and it's much easier for you to share with somebody else as well, right? Now who would like to come over here and explain this? Come, Tanmay.
Okay, so class 0 is who has not survived, and class 1 who has survived.
So the majority is class 0, which is 434.
Yes.
Non-survival, 278 survival. Okay.
Yeah.
Let's carry on.
Okay. Yeah.
Because you
0, 1. We put 0 and 1.
The overall data, you had more
Quite
people
imbalance.
who died than people who survived. The majority is the non-survival and minority is the survival.
Yeah. Okay. So we first divide the data based on the gender. So who are less than 0.5, that means towards female. Okay. So that female first we kept into the who are female, true, and it came to the left side where we got that value of those survived and the non-survived. So but the non-survived it's 68 and survived is 198.
Which one will that
Okay.
Just point your mouse here so that people online know.
This one?
No, is this?
Female
is 0.
Female is 0. Okay. Yeah. So this one actually, so in this note, we can see that more people have survived than those who are not
How
survived.
many people survived? How many people?
And total, we can see that out of 266 people, 198 people have survived and 68 people has not survived. Okay. Now, on top of that, we are again dividing it based on the no.
Passenger class.
Yeah, passenger. Yeah, passenger class actually. I think it came at the bottom.
No, that is a different class. T class is different. This class is different. classification. P class is the passenger class.
Yeah.
So you just explain this. What is this?
Passenger class.
So then you can explain these two. Or you already
Okay.
explained
Yeah.
passenger
So
class.
it's a passenger class who is actually less than 2.5. Okay. So those less than 2.5, that means female, all the females less than 2.5, and they survived.
So what does it mean? So you're actually in the right node. So we can see like out of 143 people in that node, 135 survived.
135 people
survived.
survived.
What were the commonalities that they had? What were the things that they were having?
So they are having most of the people are, so they are female,
The female.
and their P class, parental class is less than 2.5. 012. 012, yeah.
So
All
that
females.
They survived. They survived.
correct. Correct. So that means female passengers who were traveling first class or second class. I think it's a 1, 2, and 3.
Yeah.
If I remember.
Correct.
First class and second class, they survived 4.
Yeah.
I mean, in fact, almost all of them survived.
Almost, yeah.
So you have to be female and traveling rich.
Right. Yeah. Okay. And if it is greater than P class 3, there is a chances of 0.5%. Means 50-50.
Yeah, so it's 50-50.
Yeah.
So if you are traveling third class, having to be female but traveling third
Third
class,
class, you have a 50-50 chance. Okay. God can say.
Okay.
Now come to that. Okay. So if it is male now, so what is the fate of the male? So male and having a fare who has given fare less than book the ticket less than 26. Okay. And there actually we can see that on top of that we can see that whose age is less than 20. Less than 20. And there is a chance that it is also chance of that they have more non-survived, less survived actually. So male with fare less than 30, age less than 20, there is a chance of 40%. Yes. Yeah. But if it is greater than 20, and again fare is less than 7. Then there is a chances of more non-survival. Yes, 100 or no, 111 it's not survived. Only 7 survived. More deaths. Yeah.
So if you're a male who's aged more than 20, you're traveling less than 7 pounds fare, then
There is a good chances of not survive. Now, if it is a fare more than 26, and then good chance of okay, at least. Yeah. So I think overall we can say that if you are a female, you have a good chance to survive.
All confusion matrix and now find it.
Yeah. So only left side is having green or blue.
So I told you, right? So it's going to do the separation in terms of the one class on one extreme, the other class on the other extreme. So this blue means more survival.
More survival. That is
Dark orange means less survival, right? So all the survivals will come over here, all the non-survivals will go over there. So that's why it's actually splitting and creating the purity here. Yeah? Cool.
Where different other than the gender.
Yeah, I think.
You can do it by
Can-
classes.
Yeah. But how can we say that? Okay, so instead of male and female.
Oh, you cannot specify that. That is what the tree is going to do.
Okay.
Right, yeah.
They're-
No, not random. So it basically is
Jimmy,
figuring out
purity
what is
actually.
the best filter to create a less impure system for you. So there's a concept called information value or information gain.
Yeah.
Right. So it's basically looking at that information gain. So it tries internally to split by all the variables that you have.
then it will pick the best one that gives you the biggest drop in the impurity. That's how it's working. You cannot specify. Cool. Thank you. Okay. So now, anyone online has any question, folks? Or you are good? Can you confirm? Yes, no? Everybody has figured out how to get the PDF as well, right? Awesome. I am not able to hear you, so if one of you can confirm online whether you can hear me.
Yes, sir, we can.
Okay. Rajul said something, but yeah, very, very meek. Thank you. So let's move on then. We will shift gears, and rather than doing the principal component, what I'm going to ask you to do is do a quick pre-read. And then we will talk about the hyperparameter optimization because everybody was asking me that. So I think it's good that you're interested, and we will talk about that first. Article number 35, if you can just take a look very quickly and confirm, and then we'll get the conversation going on it. 35.
But बहुत सवाल पूछ रहा है। Oh yes. Character बनाना है।
And there's a link here which says cross validation. Click on that link as well, yeah. There's a link here. Important. K-fold cross validation. Correct. We haven't done the support vector, but you can just go through the flow to figure out what we're doing and how we're doing, and try to get a gist. And if anyone can volunteer to explain that. Yeah, whatever you understood. Yeah. Okay, anyone would like to explain? Ranesh, you want to try? You can pass it on to anyone. Huh? Okay, all right. C colonel and gamma are for the support vector. So, I mean, they may not be relevant with what we're talking about over here, but the other concepts are applicable. Anything else? You can also talk, Rashmi, if you have some other insight here. Yeah, yeah. Yep. Okay, great. Anything else, folks, in the class? Tejashvi, Tanmoy, you trying to understand? Okay, so I'll give you a walkthrough first in the code, and maybe that will bring you back to the decision tree example, right? So remember we said max depth is X, and immediately you ask, I mean, how did you determine what is going to be the max depth, right? So I'm saying I don't know what is going to be the max depth, so I'm going to try these different settings: 5, 10, 15, 20, and 25. So I want a tree which is having a 5 level max depth, a tree with 10, with 15, with 20, with 25, right? Similarly, which criteria shall I use, Gini or entropy? I'm going to try both of them. Min sample leaf, what is that, Tanmoy? In the end node, in the end node. So I want a tree with only 2 as a minimum sample: 5, 10, 15, and 25, right? So these are different settings of the tree that I'm going to try. Min sample split is what you're talking about, right? So can anyone tell me, if I want to try all the combination of these trees, how many trees will be building? So 5 times 2, 10, 10 times 6, 60, and 60 times 6, 360 trees you have to do to really figure out what is the best possible setting that you're having, right? So that's where the grid search really comes in, that you don't have to manually build those trees. I mean, the grid search will build that and tell you what are the best possible settings that you should be looking at. So that's the utility of grid search, right? Now, why did we choose these 5, 10, 15, 20? You could choose anything you want, right? You could take a very high value, generally speaking. So you can have a high value here, you can have a very low value here. So that will tell you the optima in terms of, where does the optima really lie, and you can plan accordingly, right? So 360 trees you're gonna build, right? And then we're talking about another thing called as cross validation. What is that? So what is the main concept in the cross validation?
Visibility or
Sort of there, but yeah, probably more. Yeah.
Yeah, I think optimization would be in the actual testing. We like to see in the training data set itself okay, how they are performing. So it should not be just mere of a chance that one training set was defined and the next went in a different direction or the different. So we are dividing the training itself into 5 or 6 or 10 different codes.
Yeah.
And taking each code as a test and remaining 9 codes taking a test. And then taking one as a test part and the 9 we create the model.
Yeah.
And taking within those training sets, model.
Absolutely. Yeah. So that's what it does, right? What Tanmay was just talking about. So the training, so if you want to do a 5-fold cross validation, so here you can see I'm doing a 5-fold cross validation and we can pass on the parameter how many folds you want to do, right? So 5-fold, 3-fold, 7-fold, up to you. Generally 3 or 5 is more common. So this training data is going to be divided into 5 equal parts. 5-fold means it will be divided into 5 equal parts. So if your training data is, let's say, 1,000 observations, that means your training data will be divided in 200, 200, 200, like 5 equal parts. And as Tanmay, I don't know whether color is visible on, not on my screen though, yeah. So in the first fold, this sample will be held out for the validation of the model. The model will be trained on this entire data. So 4/5 of the data will be used for training the model. 1/5 of the data will be used for the validation of the model. In the second split, you can see now we've taken 1, 2, 1, 3, 4, and 5 for building the model and 2 as validating the model. Similarly, you can see 3, 4, and 5. So what is happening is exactly what Tejashni, you're talking about, that we are learning from the entire data and we are validating on the entire data, even before we go to the test data, to really build a more robust model, right? But it also means that you're going to build more models. So each time you try a setting, you're going to build 5 models. Why 5 models? Because cross validation is 5-fold. So that means it's going to build the model 5 times, validate the model 5 times, right? So if I go back to the same example over here, where is it? Yeah, over here. So if I'm doing a 360 different models and I'm doing a 5-fold cross validation, that means I'm doing 360 times 5, which is 1400 something type model that we're going to build. So that's what basically the grid search really does, right? So it will give you much more robust results and it will also remove any sort of overfitting in the data that you may have. That's the significance of doing this, right? And it's very, very simple. So, I mean, you basically have to begin. So I'm just going to walk you through first, and then I will help you, ask you to build this model first, right? And then we will talk about the random forest, and then your in-class assignment begins based on these 2 things, right? So what are we doing over here, people? I'm going to walk you through first, right? So like I explained earlier on, the first thing I'm doing is class weight is equal to balanced. That you already tried last time in terms of just making sure that you are having a good balance of the zeros and ones to build a more robust model. That's the first thing that we're trying. Random state could. It's basically trying to emphasize. So if you don't do the balancing, if you have one class which is much higher, imbalanced data set basically, it will learn that behavior. So the overall accuracy, overall metrics will be saying, okay, I'm good, right? I don't have to necessarily worry about the class 1 behavior. Versus in this case, the model internally will try to optimize the correct classification of that minority class as well, to really make sure that they're also getting correctly classified. And it's spending more resources to learn the behavior of the minority class than the majority class, right? Just to really get like the idea. Of course, there's much more science and math behind that, but that's what basically primarily it does, right? So that's one level of optimization. Then I'm passing on my different things that we're going to try. And as I showed you that this is the number of model that we're going to build. And then I'm importing grid search cross validation. from sklearn model selection, import grid search cross validation, and I'm creating an object called grid. I'm doing grid search CV. Estimator is my tree, which is the balanced class. CV is equal to 5. What does it mean? Cross validation, 5-fold cross validation I'm going to do. So you can say 3, 7, and all of that. Scoring is recall. What does it mean? I want to optimize for the recall performance of the zeros and one, right? You can say accuracy, you can say AUC, you can say precision. So I'm going to optimize for the recall performance. I'm passing on my parameter grid as a dictionary. So max depth is equal to this that we have tried, these parameters, right? Similarly, you can see all the parameters will come in there. Criteria is going to be my criteria, which is what we have already specified, min sample leaf, and so on and so forth. And then we're going to fit this data on the X train and Y train, right? And then after you fitted it, you ask for what are the best parameters that you can find for maximizing my recall value. And it will say your best criteria is Gini, between the Gini and the entropy. Max depth is 5 best for you, even though you tried many depths. Max depth 5 is best for you. Min sample leaf is 20 best for you in the end node, and min sample split is 50 best for you. When we say best, what does it mean? Optimal recall performance, or the best recall performance is coming in from this setting, right? And then you can see the score coming out, right? You can export the results. I'll show you that in a minute later on. And then after we have done the optimization, then you can do the entire grid, which is the precision and the recall grid. So I get a recall of 61 for 1 and 88 for 0. Now it may be already that you are getting a better result without doing the optimization, because it's a small data. You don't need to necessarily optimize. But when you are doing that for your credit data, this will definitely help you to get a better performance of that, right? So now I'm going to give you the opportunity to go ahead and start typing the code and generate the output and confirm once you have done it. So I hope the concept is clear, everyone, right? What we're doing. So from here, you can get started. Folks online, any question from anyone?
No.
Okay, so let's start. Yeah, let's start then. And you can label that section as hyperparameter optimization. So I'm building another tree. You can call it optimized tree, whatever you want to call that. I'm calling it my tree. My tree is taking decision tree classifier and class weight balanced. Sorry? On Titanic only. As of now, on Titanic only. Same one. Yeah. Just insert a new section, say hyperparameter optimization.
What's it? You can ignore the length one, that is not needed. But then look into the line 131 and 130. Even 133 you can also use in the fitting part. Folks online, if there's any challenge from anyone, let me know. We're gonna type the line 131, 32, 33. Ganesh, working for you? Able to run? Last line, yeah. How about you, Tejashwi? Working? One more? It's really simple. The concept is really simple, actually, not that difficult.
Sorry, is there a question? If it is taking time, wait for the random forest. That's why I'm actually gonna give the random forest in the end. It takes usually some time, yeah. Hold on. Okay, so it has fitted the model. Before we go on to doing anything else, let's do this, which is, what variables came out as the most important variables, right? So the way you're gonna get that is grid dot best estimator. Best estimator is nothing but the combination of the best parameters that you have dot feature importance, right? And you get this. So let's make sure that you replicate the output, and let's see who would like to explain the feature importance over here. What does it really mean? Yeah. How? Meaning, how will it come to know? Like, what are the most important? Yeah. So, and the best estimator is that, the best model that you got. From that model, tell me what were the key features or the importance of the features that was there, right? And you will see that we'll do the interpretation in a minute as well. But let's just make sure that we get the output. Okay, everyone has the output or still working? You have the output, right? Okay. So now, Tejashri, would you like to explain what these numbers mean really? These numbers, the array numbers. Yeah, yeah, more than welcome. But actually, let me do this. Let me do this. Just give me a minute. Yeah, I will round it off to something more meaningful. So you can do np dot round and round it to 2 places. Yeah, you can sort it out as well, but the column is not necessarily sorted, so that's why I'm actually not doing it. Mm-hmm. Yep. P class, yeah. Correct. But what does 65 mean? Correct. Yeah. So if I'm looking at the overall model's performance, 65% of that model's performance is driven by gender. 18% of that is driven by passenger class. Then the next one is age, 9%, right? And if you add them all up, that's one that I'm showing here, which is the 100%, right? The next line, I'm doing the sum. I just did it while you're, so you may have missed out, right? So I'm just doing the summation as well. So the weights of all of them add up to one, right? So that means 65% of your model's performance is being driven by the gender, by the gender alone. 18% by the passenger class, 9% by the age, and so on and so forth. Fare also comes in at the 7%, right? You're right. You can sort it, Tanmoy, first, and then do that. Yeah, I'll say probably just concatenate first, and then do the sorting, right? So that'll be easier. But I'm just showing, what are the possibilities over here. Yeah. So it's not like that you've just built a model. You can also explain what are the most important features. Yeah, Rashmi, you have a question? You can drop them again. No problem. I think it will be pretty same. It should be same. So it should not be very different, but you can try it out. You can drop them and then tell us what you find out. Should not be very different. Yeah, yeah, correct. Yeah, you have a challenge, Tejaswini? This one? You've run this code? Grid.best estimator. Interactive shell is not there. Yeah. So you can type in the next line. Just put in the next line. All good? Okay, then you can move on to the best params. Best params will give you the best settings for each of the things that you've tried out. So like I explained earlier, Gini is the best setting, not the entropy. 5 depth is the best setting. 20 minimum sample leaf and 50 minimum sample split. They are coming out of the best settings that you're looking at. Rajesh, you're from batch 6 or 5? 4, sorry, my bad. So from your previous batches, we have a student. No, he's just sitting here for now. He came in for some other things. Yeah. He's just making sure I'm doing the right things. Yeah. Yeah. Best parents. Hmm? Different settings that we want to try. Yeah. from the parameters that we passed on, what are the best parameters, right? Not the like the inclusive list of all things, because that it is telling you right here that you wanted to build a model with these settings, right? So 5, 10, and all of that. From that, this is the best for you for maximizing the recall. Yeah, you can choose precision, you can choose AUC, you can choose accuracy. What do you want to choose? Right? Now the next thing that we're going to do is export this results, the grid search, grid.cv underscore results, export that into an Excel file, and let's visualize what that looks like. So the grid is the model that you fitted over here, right? Grid is this. Within grid, there is a method called as cv underscore results underscore. So I'm going to save that in a data frame called as results, and then I'm going to export that data frame into an Excel file called results. Everything is results. And when you go to your file folder, you will see there will be an Excel file, results.csv. So we're going to download that file. And then open that file. But I'll wait for you to confirm. Got it, Tejasni? Excel file is there, folks? Finish? Okay, so let's look it up. Open up the Excel file. And who would like to tell me what you think this is? Anyone online who would like to try first? This Excel file? Okay, so I'll give you a minute to chew on it and then tell me when you are ready to explain. Whatever you can. Okay. Mm-hmm. Okay. Yeah. Yeah, that's good enough. Yeah. So the first thing that you should notice over here is that you have how many rows of data? 360. So what does it mean 360? Those are the models that we've tried, right? I mean, based on the settings that we've given, those are the 360 models, right? And you can see how we are looking at 360 because it says, one model is going to be looking at Gini, max def 5, min sample 2, min sample split 2. Another model, Gini, max def 5, min sample 2, min sample split 5, right? So you can see it's trying all the different combinations that are there. And that's how we are getting 360 models, right? Is this point clear, people? Everyone? Why 360 rows? Then as you were explaining, Tejaswini, it's talking about the how much time it took to fit the model for that setting. It's basically the wall time, right? How much time it took us to fit the model. Now, this is a baby data, right? The other one that you're going to do, that will take significant amount of time to fit the model. So there it will be relevant for you to understand why it's taking such a long time, where it took longer time and all of those things, right? So that's that. standard score and parameter. I mean, it's basically the same thing as we've looked at over here. Now, this is where you will see those splits coming in, cross validation. So for split 0, again, Python follows the zero-based indexing. So 0, 1, 2, 3, 4. So 4 index, that means 5 models it has fitted. For the first cross validation, the score came out to be 0.83. For the next one, 0.82, 0.58, 0.74, 0.70, and the average is nothing but the average of these scores, right? So some of the splits did really remarkably well, right? But that's the the reason why we do the cross validation, because we just don't want to be swayed by one split only. And you can see this is basically the average that we're looking at over here, right? So this is the average for that cross validation for that setting of the model. Yes, no, clear? Rank is the best model. Yeah, so I've highlighted that. I think it's somewhere over here, but you can sort it by that. This one is the best setting. So it gave a score of 80 in the recall for that training data, not the test data. For the training data, it gave us a recall of 80%, right? And this is when it was doing the cross validation first time, cross validation second time, third time, fourth time, and I think this was the first one, first, second, third, fourth, fifth, and this is the average. Yeah. So that's the basically the cross validation score that it got, right? Now, like you saying, Rashmi, that's correct. So you can just put a header over here, right? And then you can sort this data, sort, you're gonna sort by the rank in the test score, smallest to largest. And you can see this is my top model. And that is what, rank the model is given. Yeah. And that's what it is telling you, that when you go back and say, what were the best settings? It's a Gini 5, 20, and 50, right? So if you go back to this one, it was telling you my best parameters for you are Gini 5, 20, and 50. Remember, it gave you these settings, and that's what Excel is telling you, that yeah, that indeed is the best possible model that you have. It is possible. It is possible that the multiple settings may have the same rank. Like, I mean, it may say you may get a minimum sample of 5 or a minimum sample of 10, they will give you the same rank. Then it's your choice. What do you want to use, right? It will grab the first one, first setting. Correct, correct, correct. It is possible that they exactly have the same. So you can see that, I mean, all of these are the same, but you wouldn't find like bunch of differences. Let's look at all the ones. And alphabetically, whatever came first was the one that it has told you. So let's look at these folks and see what is different in the settings. So you can see all of them are using Gini. Max depth, probably it doesn't really matter, right? Because you can see that 5, 10, 15, everything is giving you the same. So it's saying, then I'm going to be parsimonious. I'm going to go with the 5 level of depth, because why to have 25 when I'm not finding any incremental gain? Rest remains the same. So max depth basically becomes a mute exercise there. So it's saying, you can pick 50 also. But why would you pick 50 when 5 is giving you the good level of accuracy, right? It's a simpler model. So basically, in this case, Gini, sample leaf, and sample split are the more important factors than the max depth of the tree. In certain cases, it might be max depth, which is actually overshadowing other parameters, right? So this is like, it makes our job so much easier to figure out what are the right settings and how do we actually get to those results, right? So that's what basically the grid search is all about, right? And we got the score of 81. I think that was coming out to be there as well with the rounding. The score came out to be 81 recall for the train data, right? Now you can go and make the prediction using this, right? So just like, you have done the prediction for everything else, now you can make the prediction using this. So again, you will use grid and say predict on X text. and then do the classification, confusion matrix, everything remains the same. Done? Okay. So that was like, entire walkthrough. I'm not going to talk about the probability and threshold optimization. Probably I'll pick it up in a different session. But now in interest of time, what I'm going to do is talk about random forest so that you can actually build the entire thing either one using either one of them, right? So what is a random forest? Anyone knows?
Okay, yeah, because so it's the field that is we are giving the parameter that needs to be. There is, I think, one more where I will give the range, we will find out actually.
Yeah. So the same thing, the dictionary that you passed on, you can actually have a for loop there. So for X in this to this, try out all the settings, right? So you can actually create a loop there, and then that goes in basically as a value of the key value pair in dictionary in that. So you can try out different settings. That can be done, but that's probably over optimization in my view. So here what you can do is you can try out a very small value and very big value, and values in middle to give you a good sense of where exactly my optimal lies, right? So for example, over here, if you're not convinced that we've maxed out because it said somewhere over here like 5 here and sorry, I think 20 here and 50 here, right? So we're already past that area. But you can go further, like, why not try 30, 35, 40 as well, right? That will give you a good idea whether you're actually getting to that stage or not, right? Okay, so now we will move on to the last topic for the day, and then I'll give it to you to work on it together, which is the ensemble model, and we'll look into the random forest. Article number 49, if you can take 5 minutes to quickly go through it again. All of these were assigned as the homework, so I hope you have already done the pre-reading, but if not, then you can take a quick 5 minute and do it now. 49, 49, yeah.
And so can you go to that prediction one line?
Yeah,
Actually, I'm
yeah.
getting error.
Okay, sure. I'm gonna go there, Bhavna. Just a second. Okay. This one?
Yeah, correct. I'm getting error on printing.
You want to share your screen?
Okay, yeah. I didn't input the predicted.
Okay.
Yeah, it's working now.
Okay, fair enough. So we talked about the hyperparameter grid search. Now we're gonna talk about ensemble modeling. And model fitting is not necessarily that hard. Just like the concept, understanding this will be slightly tricky, and hopefully you'll be able to get a good hang. And in the meantime, I'll just make sure that I have a random forest code over here as well. It's literally not different from a decision tree, but you just need to understand the difference between a tree and a forest. Correct. You're building a jungle now, not a tree. Correct. Yeah, that's the intuition behind it. But how is what is there in this article? We can take a look. I'll give you 5 minutes. Yeah. All right. Anyone would like to explain? Or you're still going through? Have you talked about this grid? No, we haven't talked about that.
No.
Okay. Okay. Got it.
By what amount is the variance of difference like between them and bias is like whether I'm biased towards this or that. So yes, both of them are so difficult that when you try to fix something that this may not fall into. Maybe this model will try to address all of them.
Yeah. That's the broader gist, yeah. But what is bias then? Bias, not your bias or my bias, but the model's bias. What is it?
It might be biased towards
It's a wrong term actually. So let me just say bias is more in terms of how accurate you are, and variance is how precise you are. You understand the difference between accurate and precise?
yes.
What is the difference?
Now we are getting confused. One was the accuracy and the other one that you were.
No, this is not the accuracy and the precision that you're talking about.
Accurate? What was the other one?
Oh, sorry, hold on. Let me just say it this way. So let me put it in a different way, I think, because you're right. I mean, the accuracy can be misinterpreted there, right? So let me just think about variance is more about consistency, how consistent you are, right? How consistent you are, that's the variance part. And bias is how, I mean, it's more about the accuracy part, but I mean, how precise you are, for example, let's say. So you might be precise and you might be consistent, or you might be accurate and you might be consistent. Huh? Sorry? Yeah, but I mean, those are two different dimensions, right? So let's say you really, let's say you're doing the what do we call that, karting thing, right? I mean, right. So you're really bad, but you're really consistent. Like you're bad all the times, right? You're bad all the time. So that's your consistent. You're hamesa bad actually. So you never actually become better, right? So that's like you're very consistent actually. So get the points for being consistent. And you're accurate as well. That means you're actually hitting the goal post all the time, right? Or the bullseye all the time. So that's like you're very accurate. So the ideal is that you're very accurate and you're very consistent. That's the best possible thing, right? And as you said, there's a trade-off. If you try to make the model very accurate, it will work good for your training data, but the moment you fit on the other data, it will fall apart. So it's not going to be consistent. It will be very accurate, but very less consistent, right? If you fix the accuracy, you make it less accurate, but then it will be more consistent on the others, right? Because it's going to have a certain error component that we're looking at. So that's the concept over here. And any of these simple models like a linear regression, logistic decision tree will have that bias that once you try to, or I mean, will have that shortcoming that if you fix bias, variance will go off. Or if you fix variance, bias will go off, right? And they are both supposed to be lower. Bias and variance, they're both supposed to be as low as possible, that you're very consistent and very accurate, right? And that's where these ensemble models really come in because they're not one model. They're ensemble models, right? They're many models working together. So one's shortcoming is fixed by others. Like you are working together right now in a group. If you don't know something, then you can discuss and then you can fix it. Same way models work. That if I'm not able to get something straight, then I'm just gonna go and talk to my adult models and then figure out what exactly I should be doing, and then I'll be able to get a better model. And that's the trade-off part that we're looking at. That I mean, these models can make the accuracy and the consistency go higher simultaneously, or the precision or the preciseness and the consistency of the model, they can both go higher simultaneously, right? And there are many different ways of doing that, right? So some of them are what we call as a bagging, others are boosting, the third ones are stacking. And the general philosophy is it's a groups learning. So one person can be wrong, two people can be wrong, three people can be wrong, right? But if everybody is saying the same thing, then chances are very little that they're wrong, right? So same way the models, it's the same thought process. That I mean, if I'm looking at the group of model, then they will generally come out better than a single model, right? So three ways we can do that. Bagging is what we will do now. Boosting is something that we will cover maybe in advanced machine learning, and stacking is basically something totally different, right? So bagging is random forest is an example of a bagging. So in this, what happens is, let's say I have 100 trees in my forest. So first of all, it's a forest. So it's not a single tree. So you have many trees which are learning together. And you say, I have 100 trees in my forest, right? Now, each of these trees will independently make a prediction. So I'll say, what do you think, tree number one? This person is going to survive or not? The tree number will say survived. Tree number two, same question, they will say non-survived. Tree number three survived. Tree number four survived. Like this, we'll do a majority. So if 80 trees say survived, I'm gonna say survived. So 20 trees could be wrong. 80, I'm gonna go with the majority. So if 80 trees are telling me survived, then I'm gonna go with the survival as the final prediction. Like I mean, this group of people, like it's a jury, right? I mean, not everybody in jury may agree, right? But ultimately, the majority wins, right? So same thing happens over here. Everybody is independently working and so on and so forth. And this is what the concept of the bagging algorithms are. Random forest is a bagging algorithm. Boosting algorithms, some of the examples are like ADA boost, category boost, or cat boost, or XG boost. Some of those things, they work in a different way. They are working together. So for example, let's say Tanmoy and Tejashni, you are working together, right? And you're not able, Tejashni is struggling in classification of a particular class. You can say, Tanmoy, can you help me here? I'm not able to figure out what is going on here. And maybe he will come in and then help you in terms of getting the right signal. So there, wherever the classes are misclassified, the other trees will over-index. Was tree number one failed to classify this. Let me take a step. And they will work sequentially, right? I mean, they will work together. That I mean, I am trying to look at those cases where the models are not doing a good job, and let me try to do a better classification, right? Stacking is a class which is a model of models, or they're meta learners, right? And this is very common actually. So you'll see the gradient boosting tree, CAD boost, logistic regression will feed into another model, which might be an XG boost model. Output of that will feed into a category boost model, and that will also feed into a decision tree, right? So it's like, you are actually building like a Lego blocks. You have first layer of model, output of those models go into the second layer, and then third layer, and so on and so forth, right? So those are called the stacked models. And most of the competitions, like if you go and start to compete in Kaggle and all of that, your linear logistic does not stand chance at all. What will be winning the cases most of the time will be these stacked models, right? I mean, they are models on top of the models, or meta learners, right? I mean, they are much more complex, and you cannot really explain what is going on. So it becomes truly 100% black box, right? If somebody says, "Can you interpret this for me?" You'll say, "No, I cannot." I just know that it has done a fantastic job in the classification, but I really cannot tell you how this model worked, what exactly went on, and so on and so forth, because they are like, just too many things intertwined together to give you the best prediction. That's the stacked model. And we'll be doing all of them over a period of time. But bagging is the random forest, and we will try to do that over here in the code. So I'll just walk you through this. Everything remains the same, people. What is the new line that we added over here? Estimators, right? And this means build a random forest with 10 trees, build a random forest with 100 trees, build a random forest with 1,000 trees. So to your point, I'm trying, 10, 100,000, right? I mean, so it's 1,000 is a very, very large number of trees, right? So those I'm going to try. And everything else remains the same, except like, I mean, instead of the decision tree, you're just calling in the random forest classifier. And then you're going to build it exactly the same way. You're going to evaluate that, and it will tell you the best estimator, all of those things, right? I'm getting the feature importance as well. So you can see now the feature importance has looked slightly different. And look at the recall value. So earlier I was getting 0.61. Now it is able to boost it up to 72%. And recall for even zero became solid as well, right? So you can see these are really good learners, and they actually fix the shortcoming of a decision tree, right? So I'll give you time to type the code, and let me make sure if you have the output clearly. So just copy paste the same thing as you've done for the decision tree, and call the random forest and add certain sections and modify certain sections. Yeah, Rashmi, you have a question? It will go higher. Yeah. So the code that I'm gonna give you, the one that you're gonna work on, I don't think you'll be able to wrap it up today, to be honest. I think that random forest will take some time, right? So it can take hours and hours, and that's where, yeah, we don't run on then the local PC. Then we have to go on the cloud, either AWS and GCP and things of that nature. So that's where you will be able to get the speed. You need to have the GPUs to churn out those models. But these are like serious models, right? I mean, you are actually able to crack the problem, and you're able to tell what exactly is going on in a much better way. This one will be okay. Yeah, this one will be okay. We should never be worried about the processing time actually. So I mean, if you're working in a corporate environment, I mean, if you say no, I cannot build a better model because I don't have the processing, immediately people will jump and say, no, you go and buy, I'll give you money, right? But you give me the best possible model. So that's the mental model that people follow, right? But yeah, you're right. I mean, in this case, it's gonna bog down the system, not the decision tree. I think that should take maybe 5 to 10 minutes. I mean, for this Titanic data, the random forest, but for a bigger data, it can take hours and hours. Folks online, any questions before you run the random forest? Any doubts, questions from anyone? You can copy paste the entire code. Yeah, sorry, go ahead.
Yeah, nothing from my side.
Okay.
I was able to understand.
Okay, thank you. I think I've cut down some parameters, no? Or is it the same? Same parameters. Maybe the levels I have reduced to get it faster. Yeah, so I've tried to reduce the parameters to really get faster results. Six, 12, 16, 420. How many models that will be building? Anyone? How many models? So 3 is the number of estimators. 3 times depth is 3. So, right? So for each of these settings, it's going to build a random forest with 10 trees, with 100 trees, and with 1,000 trees. So it's all multiplication, right? So 3 here. I think let's just do the math, right? So I think some of these are typos as well. Or I mean, I haven't modified. 3 here, 3 levels, 2 levels here, 4 levels here, and 3 levels here, right? So 3 times 3, 9. 9 to the 18. 18 4 the anyone? You remember your table? 36 and 76 3 the 218 or 228. 228. 228, yeah. So that many model times 5, which is the cross validation. So 228 times 5. Number of trees in the forest. So you're gonna build one tree with these settings. Like I mean, all the possible combination of these trees. Then there's gonna be a forest. That forest is gonna have 10 trees. 10 times into each of these settings. Then 100 trees, each of these settings. Yeah. Then 1,000 trees, each of these settings. Raise your question. Good. Is it? Okay, you could change it to something else. I mean, if you want the 5-fold, that's fine. Yeah, we are doing the 4-fold, which is the 25% partition. Or you can do 3 to save time. And where is the random forest coming from? Is it coming from the tree or something else? The sklearn.ensemble. Ensemble is the different type of models, not the tree. So remember, we pulled the decision tree from the tree. This is coming in from the ensemble, or some people call it ensemble, right? So in French. Hmm? 5 minutes it will take, 5 to 10 minutes, depending on the processing. Okay, so once you get this, then any idea what came out as the best possible model from this? So it says trees 10, not 100, not 1000. 10 trees is more than enough for you to give you the best results. 10 trees, min sample leaf 10, max depth as 10, and class weight is balanced. I think we did not try one setting. I think we removed one setting, right? Min sample split is there. Min sample leaf is there. Yeah, all of them are there, no? My criteria, okay. So that's interesting. So let me just run it one more time. So maybe random forest. Ah, acha. Okay, okay. So I'm still back on that. Grid random forest. So I'm trying these settings. Genie, max depth, 1, 2, 3, 4, 5. Yeah. I'm curious, why it's not showing the other ones. Min max depth, this. So that's one setting, two setting, three setting. But what happened to the other two settings? No, no, but we have passed on 5 parameters, right? 1 parameter, 2 parameter, 3 parameter, 4 parameter, 5 parameter, right? 5 parameters we passed on, but it is not telling me the 5 settings, is what I'm curious about. Yeah, which one between the Gini and entropy is better? Which one in the end node is better, right? So I'm just gonna explore that why it has this peculiarity over here. Great random forest. Missing 2. Best parameters. There you go. Best estimator. Best estimator. I estimated. Best parameters. Right. So there you go. This is the best parameter. CV you could try 3. 4 yeah. Just to save some time, I did that. And when you look at the best score over here, it's reduced on the training data, but it's better on the test data because it's generalizable more. So it's basically saying I'm going to compromise between the bias and the variance. So my bias goes down, but I'm actually going to fix my variance part because that was 81%. But then on the test data, that came down because the decision trees overfit. Now you can see where we are coming in because they will give you super result on the training data. They will overfit and they will not be that effective on the test data. This is actually a much more moderated form. And you can see this has a better test performance from 0.61 to 0.7 to recall, right? Because it fixed that bias and variance trade-off. Any questions, folks, online while we are waiting for the code to come back? Please.
How we would test this on this temperature. How do we
If the interpretability is not a challenge for you and that is not a bottleneck for you, then you should go with a more complex model, like an ensemble model, right? Because interpretability is not a challenge for you. However, if you want to build something which is much more easy to interpret, then you should look into a decision tree or linear or logistic or something of that nature. Because here it's sort of like, becomes a black box. I mean, here you can also get the feature importance, but in some of the more complex one, that will be slightly more tricky, right? To do the attribution to the specific variables. I think even some of the more advanced techniques now are, in a way, giving you that feature importance for even the complex models. But I'll say if interpretability and legal and compliance and any of the model validation is not a challenge, go with a slightly more complex one. Or the algorithms like PyCaret or H2O and stuff like that, they will build all these models for you. You just give them the data to those packages, they will all these models and they will tell you that in this case, random forest is the best one for you. In this case, logistic regression is the best one for you. So you can become more lazy. Huh? Feature engineering. I told you very beginning that what you're doing right now is the most important thing because some of these AutoML packages will take away some of this customization work. They will try even more settings than you can imagine, like the learning rate and all of those things, like way too much. But the data that you feed in is something that you have to really control. Understanding the data, understanding what makes sense, what doesn't make sense, how we should impute the value, what outlier treatment makes sense, how do we clean the data. That's the most important thing. You're needed for the data. No, not just the data cleaning, but the feature engineering. That's the more appropriate way. So that's what basically it is, because these AutoML packages will just destroy your models. I mean, whatever you build by hand, I mean, they will go over that in no time. Yeah. Domain knowledge and plot your data. I mean, because a lot of times even the expert will not be able to tell you things where you are analyzing the data, then you are able to tell. Well, like looking at the distribution, looking at all the plots, scatter things and all that. Yeah. So that will tell you much more than the experts. It's not to say that you don't have to build the models by hand. I mean, 90% of the people build the models by hand because ultimately you have to get the approval, the interpretation, all of the things right. But I'm saying, like, if none of these things are challenged for you and you're running your own startup, and you just want to do like the best classification possible, some of these AutoML packages will give you that result right away. Yes, that's exactly how people use it. So they can figure out what is the highest level that I can accomplish, and then they will go back to build a simpler model. Because if I build a stack model, imagine I'm presenting it to somebody who has never seen a model, and this is boss, explain karo usme kya ho raha hai. And I said, this is a stacked model on top of an ensemble model and this and that. They'll say, okay, I don't know what you're talking about, right? I mean, and versus if I show them a decision tree, they'll say, I can follow that. Yeah, yeah, I know this is happening and all of that. So it's much more visual. These things are not visual at all. These are black box. Anything, classification, regression, both. Random forest is actually one of the most heavily used models. And in the banking, what is the most heavily used model? Like the controlled industry. Any guesses? In the banking industry, what is the most used model? Logistic regression. Why? Because these auditors and the government agencies don't understand other models. So if you build something, they will say, I don't follow that. So your approval will be like not going through, or you'll be getting in trouble that your model has, uh, has used a bias for African Americans, for example. Show me how your loans are given in fair and equitable fashion to the white Caucasian population and African American population. If you don't understand your model and your model is a black box, you yourself don't know what is playing a role. And if they do the back engineering and they figure out, was these 100 people, African Americans, were exactly similar to these white 100 Caucasian people, and your model gave more loans to those, you're in trouble. Multi-billion dollar loss your bank has to take. Then you can use the like the stacked models because you're not regulated. Your only purpose is to do the best possible prediction. Nobody's asking you. Like, I mean, it's your own business, right? I mean, RBI is not going to come and say, hey, why did you make the wrong guess on that car, right? It's between you and the customer. But if when you're doing, something which affects the broader society, which is like, the pharmaceutical industry, the financial industry, right? Things of that nature, that's where you have to be very careful what models you're using because they should be 100% transparent. Like any auditor comes in, they can see through your model, like which variable came out, why it came out, all of that. If you're just trying to do a best possible prediction, nobody cares how you got it. Build the AutoML models and stack ensemble models and all of that, and they will give you the best possible result. Good questions, though, yeah. So right now, I mean, you say, okay, I have gone through the entire like list of models here.
Provided the content that you're working on. So knowing them what they do, how we are doing it,
Yeah.
it's on towards the side of it. But
Yeah.
why we are actually, if you're not able to get to the platform, if you have to label me as a right data scientist, first I need to get to the core of it. What is the cost for me going this? So if I'm able to get that, then
yeah. True. True. Yeah.
I feel myself in that.
Yeah.
We're learning so much, but how do I translate them? What to be used? And that is the most Python kind of what's probably the difference. This one is not taken there.
Yeah. I mean, just to make you even more confused, there are packages. There are packages which you don't even have to tell was your regression or classification. You just say this is what my y variable is, and they will figure out based on the variable themselves that it's a regression problem or classification problem. So you don't even have to think about whether I should do a classification or regression. They will make you that lazy. You just tell them this is what my y is, this is what my x is. and you say, I'm lazy enough to not do data cleaning also, you do it, and they will do it for you, right? But you will get the suboptimal results. And when you're talking about like, the industry performance and competitive things, even like 0.0002% performance difference in the model will be the difference between the winner and the 70th rank, right? So you're talking about that decimal places actually. So those are the ones where these sort of things will come in, where the feature engineering, whether you did missing value imputation with this or something else, or that could be a difference between your conclusions being effective versus totally being bogus. So let's say you build on the credit and you said, you know what, credit score doesn't matter in my model, right? And you have like very good precision, very good recall. And you think in my model, my credit score doesn't matter. And then you go to the business and you say, are you serious? Is your model right? Right? Because you have some goofed up something in your like other things, right? So you cannot make any conclusion which just go against the normal business judgment or I mean the intuition behind that, right? So those are the some of the things where these models can fall apart, the tricky ones, because they will do so many inherent feature engineering. What they do is they create their own features. If you give them the 25 features, they will create 2,500 features internally. Like they will divide this, square this, exponentiate that, all of those things they will do internally. And they'll just put that in the model. Sometimes you're lucky that they come out winner. Sometimes you'll get completely messed up. Right. So that's where people focus more on interpretable. At least I know what is going on. Like, I mean, you go to a car mechanic, something was severely wrong, and they fix and they give it to you. Sir, fixed again. But you don't know what was problem, right? I mean, it's always bugging you. What was the problem? Why did it happen on the first place? And how do I know it may not happen in the future again? You just fix it and give it to me. I go for laptop repair and say, "हो गया sir, 3,000 rupees." I say, what was the problem? Motherboard में कुछ था, right? And you just keep on wondering it may happen again next time, and so on and so forth. So that's where the model interpretability really comes in handy. That you can explain, what is going on. If my variable changes in a certain way, how will it affect my model performance? All those things, right? You have the output now? Not yet. Still going through. Nobody has the output. You have it. How's your performance looking? Hmm. Oh, 100. You are going up to 100. And what is your recall value for the class 1? You haven't done that part? You can do it actually. Then let me know. And another thing you would notice, folks, over here, like a decision tree was very binary. It was like way overbought on the gender, for example. It was saying passenger. What was that, right? I mean, the siblings don't matter to me. Gosh, don't matter to me, right? Versus a random forest, you can see it's more balanced. It's, everything matters to me, right? I mean, there is a certain significance and all of that. So you can see it's much more balanced model, and that's why it's having a much better prediction power as well. So over here, I mean, you can see the order remains the same. So it says gender is the most important, passenger class is the second most important, age is the third one, but it's giving certain weightage to all the remaining parameters as well, right? In fact, fare has popped up. Fare has become the second most important in random forest versus a decision tree, right? So you can see there are differences which come in when you look into the ensemble model. They look much more balanced actually overall, much more stable. How much? For one. Yeah. Hmm. So it has come down. So you're that, huh? So there was some overfitting happening, and you were lucky in that training data. If you had provided one more sample to that decision tree, maybe the value would have come down. So just happened to be in the right place in that particular model. So now your assignment will be You have to do exactly the same thing as what you did for logistic regression, but now you're going to try both decision tree and random forest with the best possible hyperparameters, and then report back the recall. And you have to optimize for the recall performance. Remember the loan example that we're talking about, the defaulter versus the fully paid, right? Or I mean, I think it's not defaulter, but last week data only. The challenge there will be it's a humongous data. So you have to be, so you have to be, yeah. So you have to be playing with, like, I mean, how much data you want to grab. So maybe you want to do a threefold split. One is training, the other one is test, and the third one is validation. So you can do some research. I'm giving you already hints. So don't do fitting on the entire train data. Do the training, test, validation. So training is when you train the model. Test is when you actually like test out the parameters, and validation is another validation of how good your model is. So that will give you more confidence on how robust your model is, and then see which one is the top performing model between a logistic, decision tree, and random forest. So if you know these three, your classification job is done. Any problem to your question, Tejasvi, can be handled by these three: logistic, decision tree, random forest. They will be like within 10% of the best performing model. Within 10%, right? I mean, most of the cases, it wouldn't be day and night difference, right? And then we will do exactly the same thing using linear, decision tree, and random regressor. So random forest also has a regressor, right? Not just the classifier, but the regressor as well. So that can be used as well. So that can be done, right? So we will pick another example someday where you can do the regression exercise on a random forest. Yeah. Other techniques, I mean, like a support vector or KNN or other techniques out there, they don't come close to the decision trees actually, or the tree-based models that we're talking about. And there's a whole like family of tree-based models, like XGBoost, gradient boosting tree, random forest, decision tree. Trees generally perform better compared to some of the simplistic model like a KNN or support vector classifier or support vector regressor, right? They are harder to train. Trees are much more robust. I haven't seen, like, to be honest, a lot of applications of support vector, for example, in real world. If you ask finally, what is your model that you are looking at, they will say either a stacked model or a random forest or a decision tree or a logistic or a linear. Very rarely you'll see SVC coming floating on top and beating all the other decision tree based models. So trees generally beat everything else. Why? Because they are very, very intuitive, right? And they are not like stuck to a particular limitation in terms of their understanding of the data and all of that. So that's where really it comes in. Be wary that when you're fitting this random forest, it may take upwards of 6 to 8 hours to get the results, right? And make sure that your computer is not smoking during that time, right? Or you're better off putting it on the Google Colab and running it there. Or you can take a random sample of the data. So I'll just leave it to your imagination. So next time when we come back, we'd like to see who got the best performance on that data. It could very likely be the case that you get a precision of 1, recall of 1 also. In the credit data, in decision tree or logistic. Titanic, yeah, but not on the credit. Loan data, you got a 1. Okay. So then play with the smaller set of data. Ramesh, if you already got a 1, just play with a smaller set of data. You may divide also that you can try decision tree, you can do a random forest rather than one person doing it. And then when we come back next lecture, we will begin there and find out where we are. Pranesh is already setting the ball, the bar very higher. So he's saying that he already got 1 recall. Folks online, any questions before we wrap up for the day? So I was planning to leave early, but then I thought that let me cover this topic because it will give you more. Yeah, still running, right? You can stay on. I mean, you can give it some time. And this is running on Collab. What is your RAM? 8 GB should be good enough. 16 GB should be ideal. Yeah. No, but don't worry about it. I mean, you can always like take a package from AWS or Google, right, or Azure, and you can run it there on the cloud. Anyways, machine will not take you to the serious data related things, right? So it's always going to be the cloud platform. So you fire up your query on the server. You fire up your query. Huh?
One thing, so we are doing that probably because the innovative, okay, whatever. So in the what they are doing. Every day we can build one model.
No. Every day one model. One model will take 3 to 4 months actually to build. Because first of all, you will spend. You will not get the data to begin with. You will not even have the data. So your boss will tell you, somebody will tell you, "Jao Tanmoy, build karo this model, right?" And then you go to somebody, why do you want to build that model? Somebody already built 6 months back, it's not working, or you already have a solution in place. So you just go to the bureaucracy first. Then you will get the data. Then you will start working on the data. Then you'll say that there are gaps in the data. Then you'll have to work with the data software engineering team to figure out what exactly is happening. Then you'll figure out, yeah, it makes sense. Then you'll go to the feature engineering, understanding that, right? That will take months, right? Then you will get to the final building of the model.
I have a similar project.
100%. We're all waiting for the model results, yeah.
Optimize processing whichever way possible. And he gets to work with the data that he showed me was related to employees and their work. Their monthly billing based on the efforts they have put in, the number of days now. So first he started with the data that he was getting from XYZ person. He started working on a model. Think about the project management with optimization of 2,000 employees. Okay. Now what happens is, rather than he's getting to understand the process, he's getting nearer to the final source of truth. Okay. That is finance. So finally he gets that, and once the whole automation project is completed, then we get to know that instead of Excel doing the unpivot thing, you have the option available in Power Query. Otherwise, Excel wise, if you have to do unpivot option, you get a table with months on the header. You have to bring it to a table so that you can do some pivot structure. Now doing that to unpivot, otherwise automation in Excel. Finally, create a model. Okay, we get to see that the finance team has done a shift for the past couple of years. Okay, and there can be huge optimization possible. But the question mark comes back to the final finance team doing the work. Okay, if this project comes to hand, then our previous work becomes a question mark.
Oh, yeah, of course, you have to defend that.
And that is when they go to the senior leadership and this project is like that. Perfect. But it didn't happen. If the model was prepared, it showed the optimization, just that we did not get buy-in from the last level of people. And when they found that it's against them in some way, that it is not partnered with us from the beginning. So they did not get attached to the project mentally. They were just a giver of the data, not a worker of the thought process of the project. So finally, when they understood it's going against their leadership,
because a lot of people could lose their job, right, or whatever, right? So it doesn't happen in all the companies, but yeah, I mean, definitely, all those things are there. So the other thing I haven't covered, Tanmay, for you is when you have a brand new data, the understanding the data itself takes very, very long period of time. You have to get the InfoSec approval to access that data. You have to think about how you're going to fetch that data in the model, right? You have to do a lot of research what exists in the market. So I'm just looking at my team members, what they do, right? So I mean, a lot of times they have to do research, and that's why they're called research scientists, right? They're not just executing things; they have to do the research also. So if I'm giving them a computer vision problem that identify whether this is a fake image, let's say what happens to something gets delivered to you which is non-returnable, right? Like like fresh item, like the juice can, right, or oil can, and people may say, when I got this product, it was already broken, right, or the oil was coming out and all of that, right? So it's not returnable. So now you will the customer will keep the product and get the money as well, right? So you have to detect how that image can be a fraud image. So imagine if I give you that open-ended problem, how would you go about that, right? How would you go about building a computer vision model? So you have to do a lot of research. What exists in the market? How do we detect that? What are the modus operandi which happen? So it's all part of the data scientist job. Actual model building is not that big deal. Looking into all these things are very important. And then once you have the model, then how do you deploy the model? That's another nightmare. You have to feed the data real time. So let's say I'm calling to the customer service, right? The mask that you shipped me is a defective mask, right? And I have to make a decision right there that tomorrow, don't worry, I'm going to ship you a product or not, right? So that means the model has to do the scoring in real time. So you say, customer, please upload the images. You upload the images. So those images need to be run through a model. And then all the parameters need to be pulled in, right? Model needs to spit out the score, and then it has to be available within microseconds for the CSS to make a decision, right? So the real-time implementation of the model is also very tricky. That's where you will sweat a lot. Correct. Correct. Automated. Nobody's sitting and looking at that's basically the OCR, right? I mean, from your government IDs and all of that, they're pulling the information, matching it to the legit government ID as well. So if you upload it like an ID, they will tell from. Yeah. 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 And the training itself takes days. So the training is not going to happen like this. Training will take days, and that too on cloud. So if you ask what is going on in the model, sir, I submitted last week. It's running, right? So it will come back. Then you know what are the parameters that you're actually looking at, because you're dealing with millions and millions of observations, right? So when you're actually doing it in the real world, and then every 2 bips increase in precision and recall will be a brand new challenge for you. So if you go and present and you say that I am not happy with 75% recall, make it 80%. You've gone for two months just to really go take it from 75% to 80% again. Then all these things will come in handy. Let me just do this. Let me just do that. See if I can get that extra juice out of the model, right? So that's where the real action lies. The first cut model will be almost answering the question, but will never be the final product. To get to the final product from the first product will be weeks and months before you actually get to that stage. So I hope it's not scaring you.
Just with your classes, how about if you put into action?
Yeah.
About the closeness where data was so much of how to
From here only, from just some other institute. Okay.
so looking at this project, I was verified.
You'll be able to do it. Don't worry. So I will tell you, like, and you can talk to, some of your students, like, some of the people who didn't know ABCD of the Python coding, then they developed a very good working product as well. So it's just like, every single day, if you keep on doing certain thing over a period of time, you become better over, a long time period, like, year and a half, 2 years, right? I have a lot of examples. I'm not going to name them, but people who couldn't necessarily code anything, they actually developed a solution which got highlighted in some of the big forums, and they are working as a full-time data scientist now. So yeah. So it's not.
Please actually, after knowing this, are doing something.
So it's not going to happen right away, though, right? I mean, you have to keep on adding the things. I mean, whatever I teach, for example, I mean, if you think that, I mean, I knew all these things right away in day one, no. If I teach one class and go to the next class, people ask me a question, I become better over a period of time. I don't like study proactively for these things, right? But if you ask me to teach completely new topic, then again, I have to go and study myself, right? And so a lot of investment in studying, reading, looking at the work of other people will actually get you in that direction.
Yeah, I was happy to see this project. I was able to understand this project.
Yeah. I mean, there are tons of examples within Reva also. People successfully able to build a product, doing phenomenally well in their capstone, able to leverage some of those things in their work as well, right? And I have given some of the ideas to some of the people in the capstone, right? So they are working on those things as well, or they've already submitted. So I mean, it doesn't, and you're not alone. I mean, it's not like, I mean, you will be just thrown in. You also go figure it out, right? I mean, you will of course have some help, but every single day, every single hour that you spend counts. And if you think that's going to be like your engineering examination, I am guilty myself that don't study and then study in the last 15 days or 20 days. It's not going to work. That is not going to work. You have to, huh? Yeah, correct. So it should be your passion actually. So that I mean, when you have time, you would like to go and take a look at what is happening and do that, right? I know it's like a extreme, but I mean that's how you should be thinking about that. This is what my passion is, and then you get there. If you're passionate, if you're putting time, you'll get there. If you're just doing it for the sake of, it looks super cool to be there and data scientist and just be attached to it without doing any efforts, you'll spend years. Cool. It's a wrap from my side. How about you? You have a code or output? Nope. Why is it taking such a long time? Usually should not take more than 10 minutes. Yeah, that's something 7, 8. Okay, folks, online, any questions before we wrap up and end for the day today? Yes, no?
No, sir. We have to work on loan status, is it?
Yeah. Prajwal, can you create that LMS entry?
Yes, sir. I'll do it by evening, and I'll send them the link also.
Yeah. So the same data that they worked on, exactly the same thing that they did for the last exercise, but now they have to add on decision tree and random forest in the mix and optimize the parameters for logistic as well. Yeah.
Sure, sir.
Okay. Thank you, folks. Have a good weekend. Take care. Bye.
Thank you, sir.
Thank you. Thank you, sir.
Thank you, sir.